Hello children, welcome to the session. Let's continue with reflection of light yet curved surfaces. So in the previous class we have seen what reflection is, what terminology you are supposed to be aware of in discussing this topic further. All those basics are dealt. Just let me start with a recollection of the previous class. So in yesterday's class we have seen that if there is a plane mirror on which if a light ray is incident, so at the point of incidence you have to imagine a normal, and from there the ray is reflected back into the same plane, making the same angle. Angle of incidence is equal to angle of reflection. So there we took, while discussing the reflection in detail, we took only one ray. And here we are taking parallel beam of rays. In this beam we have taken three rays. All three are parallel to each other. The parallel beam of rays are falling on it. So since this is a polished, optically polished surface, you can see that the reflected beam is also with parallel rays. Is that clear? So when a beam of light rays, parallel beam of light rays fall on the optically polished surface, you can see that the reflected rays are also parallel to each other. Thus the angle of incidence is equal to angle of reflection, angle of incidence is equal to angle of reflection, angle of incidence is equal to angle of reflection. Yesterday only we discussed one more point, saying that a line is a set of infinite points. So here wherever the ray is incident, we are imagining a normal. For the first ray here the normal is, second ray here is the normal, third ray here is the normal. And with respect to the normal, this ray is making an angle of I, and then the reflected ray also makes the angle equal to that of incident angle from loss of reflection. So this is how you have to imagine, like wherever the light ray is incident on the surface, there everywhere you need to imagine a normal. So we must understand that there are infinite normals. Yeah. For a plane surface, the normals are again parallel to each other. Like this. Suppose take a rubber pad. On the rubber pad, just you insert the nails like this, parallel to each other. So now this is making an angle of 90 degrees with the surface of the pad. This is also making an angle of 90 degrees with the surface of the pad, and this is also making an angle of 90 degrees with the surface of the pad. So therefore you can take these three as normals. This is the case of a plane surface, like how you have it here. But our topic is about curved surfaces. So now we need to convert this plane surface into a curve and observe the phenomenon. The job is very easy. Same rules, same properties. The only difference here is that till now we discussed it on plane surface. Now we are going to take this into a curved surface. So we must know how the normals will turn into. See this rubber pad, the flexible rubber pad, just you bend it like inward. This will form a concave curve. Where the nails are there, on that side you turn all the nails inward. So it forms a concave surface. It's a curve. You can see that all the nails will be changing their position in such a way that if you extend the lines joining the nails, all these will converge at a point. All these will converge at a point. That point is the center of curvature of this curve. This point where the nails seem to go and meet, or the lines passing through the nails seem to go and meet, that is the center of curvature. Now again another word, center of curvature. So this is from geometry. Let us recollect the geometry part now, a little bit of. Suppose you are taking a circle. In fact, here I have to take as a sphere, but it will be easy for you to understand this in case of a circle. Okay, take a circle here. So if this shape comes to be like this, let us suppose that what the shape, the concave shape that you have imagined here is this curve. Now all the normals, that means what were the perpendiculars before to this surface, tend to meet at this particular. This is the center of the curvature. This is the center of the curvature. That means how to put it in the form of a definition. If you extend this curvature to form a complete curve or a closed curve, the center of that curve is the curvature, center of the curvature. So whichever curve you are taking, the curved surface you are taking, if you try to complete that or close that curve, there will be a center to that curve, right? Suppose if I am going to complete this curve, yes, this is a closed curve now. The center of this curve is this. This is called the center of the curvature. Center of the curvature. So from here you can understand that normal to this curve here. See, if you can keenly observe, this is making an angle of 90 degrees here. This is straight here, making an angle of 90 degrees here. Okay, so like that at every point you can see that this forms a normal, that is a perpendicular to the surface. In the whole curvature between any two points, very nearer points, the shape of that will be a straight line, right? To that straight line, now this is making 90 degrees. Hence this is a normal to the surface at this point. At this point where the normal is, this is how the normal is. At this point where the normal is, this is where the normal is. So all these normals tend to meet at a point, and that point is the center of curvature. Center of curvature. Why are we discussing all this now? Because when you want to observe the behavior of the light on the curved surfaces, yesterday we already discussed. For discussing the behavior of the light, we need to have a normal passing through that point. So thus we are discussing about the normals. First of all, we should know how the normals will be. So this is how the normals will be in case of a concave curvature. Okay, so now the same thing. If the rubber pad is bent in a manner that all the nails will be on the outer surface of the curve. So previously you have bent the rubber band inward. Now we are going to bend the rubber band outward. So at that time all the nails will be like this. The same concept here. Now as you extend the line through the nail, all these lines meet again at the center of curvature. Here also the same concept. How the curvature center is formed? Just try to complete the curve. It forms a circle. Center of that circle is the center of this curvature. Center of that circle is the center of curvature. So basic principle what you have to remember is, in case of curved surfaces, the normals drawn at different points always try to meet at the center of the curvature. At the center of the curvature. or rather simple, very simple way of saying is, always the normal drawn at any point on the curvature passes through the center of curvature. Passes through center of curvature. See, it is very easy now. Suppose if I am drawn, it passes through the center. Here I am going to draw a normal. Yes, this passes to the center of the curvature. Suppose here I am going to draw the normal, it passes through the center of the curvature. Is that clear? So, this is inward curve. That means the surface where you want to study about the incident and reflected rays is inward, then it is a concave. And if that surface is outward, it is an outward curve. That means it looks as though it is bulged outward. Then that is called the convex surface. That is called the convex surface. Right? So here this is how the normals will be in case of curved surfaces. Now what did we discuss here? We now are trying to discuss about how the normals will be in case of curves. Okay? Just pause the video for a moment and then try to draw these diagrams and try to understand the concept. Right, now let's come back. So when we have taken concave and convex curvatures, we have seen how the normals are. The normals tend to converge at center of curvature. Right? Center of curvature. Now let us extend the topic with concave mirror and convex mirror. Concave mirror and convex mirror. Right? So let me draw a concave mirror here. So it's a concave curve. This is the polished surface. So this is a silvered side. This is the reflecting side. This is the reflecting side. Right. To understand or to draw lines properly, we need to take the help of another reference line in case of curved surfaces. Very simple. So you know the curvature, center of curvature. So let me complete this curvature like this. So here lies my center, right? Here lies the center. So to avoid confusion, I am just erasing this part because it's already clear for you that this is the center of curvature. Now the next point is draw an imaginary line. Draw an imaginary line passing through the geometric center of this curvature and the center of the curvature. Okay, so this is the thing, midpoint. Let us suppose that this is the midpoint. Now an imaginary line which is passing through this center of this concave mirror and the center of curvature. What is this? Pole of the mirror. We call it to be pole of the mirror. So this pole of the mirror is a geometric center. If you see that for this only object, you are not looking at the whole curve. You are only looking at this device, a concave mirror. And for this concave mirror, this is the geometric center. Okay, so that means this side the lengths are equal on either side. So through this point as well as through the center of curvature, if a line is passed, this line is called the principal axis. This line is called principal axis. This line is called principal axis. So the line, an imaginary line which passes through the pole of the mirror and center of the mirror is called principal axis. Okay, so now this is the center of curvature. Like how we discussed in the previous class, let me study the behavior of light ray which is incident at this point. So my point of observation is here. I want to study how the light ray will get reflected if it is incident at this point. What am I supposed to do now? Yes, I have to draw the normal first. So let us draw the normal. In case of curvature, how the normal will be? Normal passes through center of curvature. Normal passes through center of curvature. See, this is the normal. Why am I drawing this normal n? Why am I drawing this normal n here? Because I wanted to study the behavior of the light ray which is incident at this point. Therefore, at that point I wanted to draw the normal. Thus I drew it. And you know pretty well that in case of curved surfaces, normal passes through the center of curvature. This is our center of curvature and through this it is passing. Clear? Yes. Now let us go over this. Let me say that this is the incident ray. This is the incident ray. Okay? IN. So IN is the incident ray here. It is making an angle of small I. It is making an angle of incidence, small I. How did we define angle of incidence? It is angle made by the incident ray with the normal, not with the surface. Angle of incidence is the angle made by the incident ray with the normal. Be clear, it is not with the surface. Right. Now, this ray should get reflected back into the same plane, making the same angle again. Let us suppose that this is around 30 degrees. Let us suppose, I didn't measure it, right? Let us suppose that it is 30 degrees. So your reflected ray also should make an angle of 30 degrees with the normal. Yes, am I right? If the incident angle is 30 degrees, angle of reflection should also be 30 degrees. This is the first law of reflection. Okay. So, this is how, okay, this is how the ray will get reflected back. Making an angle R where angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Why did we do all this? We did all this only to study on the curved surface how the ray gets reflected back. On the curved surface, if the ray is incident, how the ray is getting reflected back. This is how the ray gets reflected back. This is how the ray gets reflected back. Is that clear? Again, I will repeat this once again. I have considered a concave mirror. What is this one? Concave mirror. Right. This is the reflecting surface and this is the silvered surface. To have a reference line, what did we take? Principal axis. Center of curvature obviously lies on the principal axis because as per definition, principal axis is the one which passes through center of the mirror and the center of curvature of the mirror. You know the meaning of center of curvature now. So where center of the mirror we call it to be pole. So an imaginary line which passes through or which is drawn passing through the pole of the mirror and the center of curvature is called principal axis. Done. We are done with that. Now I wanted to study the behavior of the ray which is incident at this point. To study that, what should I need? What am I needed? So I need a normal here. So I do the normal. Here we already have seen practically that the normal passes through center of curvature. Yes, the normal passes through center of curvature. Therefore, I drew a dotted line passing through the center of curvature. Right. And now, I took IN as the incident ray. It makes an angle of I with the normal. And from first law of reflection, the ray should get reflected back into the same plane from this point with the same angle. So if I imagine it to be 30 degrees of angle, here also it should have same 30 degrees angle. You need to use your common sense only, like to see whether it is these two angles are equal or not. All the time you can't take a protractor and sit and measure these things, right? Yes. Now this is 30 degrees and approximately to 30 degrees I drew a line. Oh, this is my reflected ray. How do you differentiate? Everything is a straight line here. Now we already learned that to identify the ray, what is important? The direction in which the ray is approaching or moving away from the surface is very, very essential. So here is the incident ray, the ray is approaching the surface here, and here the ray is moving away from the surface. So you can see these two arrow marks. One is towards the surface and the other is away from the surface. This is how the reflection takes place at a curved surface. And the example what we have taken here is concave mirror. It is concave mirror. Ray optics, you are supposed to practice the diagrams, keeping the complete concept in your mind. It is not something like that you can by heart, this one I wanted to draw here, this one I wanted to draw here, then afterwards this. Absolutely wrong. You have to first consider which optical surface you are taking, then the principal axis, then the normal, then the incident ray, then see how much angle is formed approximately, try to observe, and then with the same angle you need to draw the angle of what I mean is reflected ray. Clear? So please children, never make a mistake of taking this as a one direct diagram and you can draw in whichever direction you want. No, it is not the right way of doing it. Fine? Okay. Let me proceed to the next. We have taken concave mirror. Means this case. Now we are going to go for convex mirror. We are going to go for convex mirror. So I don't have enough place here. So let me clear this. Okay. So if I want to take it as a convex surface, this is the reflecting surface because it should be bulged outwards, and this is the silvered surface. That means it's just a kind of curved glass where the inside surface is silvered with opaque material. Thus it will become a polished, completely polished reflecting surface. And this is the convex surface. As it is, you need to draw a line, right? So let us imagine, let us locate our center of curvature here. So thus I drew it as a circle. If it appears as a circle, it's okay. If not, please you try to make it a perfect circle, right? So this is C, center of curvature. Now let me remove this. Once when I am able to locate my center of curvature, this is the pole of the mirror, center of curvature. Now the principal axis passes through these 2 points. An imaginary line drawn passing through the center of curvature, and pole of the mirror is the principal axis. What is that? Principal axis. Now this is my reflecting surface. degrees. Please by mistake also don't take the ray from this side. So this is the reflecting surface here, the polished reflecting surface. Here it is this one. So hence it is concave and this is convex. Convex mirror. Convex mirror. So now what should we do now? We have to look at a point where we want to observe the behavior of the light ray. Let's do it. Here, I want my point of observation to be there. Okay? What should I do now? Yes, draw a normal. Normal to what? To this surface. So you can take again a protractor and then draw a straight line here and then take 90 degrees. You have a concept already that the normal to curvature always passes through the center of curvature, right? So therefore let me draw a dotted line passing through center of curvature and making the point of observation. This is the normal. Let me say that this point is N, right? And now, from which direction I have to take the incident ray? From this direction, because this is the reflecting surface. This is the polished reflecting surface, right? So, let me take, this is the ray of incidence. Okay, right. So, with the normal, let us suppose that it makes an angle of 25 degrees. Just like that, because this gap seems to be less, I took it as 25. Right? 25 degrees. IN is incident ray. Now you people can continue with this, I think. Now the job is to draw the reflected ray, obeying first law of reflection as well as second law of reflection. Second law of reflection says within the same plane. That means it should come back into the same plane. Yes, making the same angle. So with an angle of 25 degrees, this is my reflected ray. Okay, so this is how the light ray behaves when it falls on convex surface. Here it is on the concave surface. Behavior is the same. The only difference here is that the curvature what you are taking here is a bulged out and this is one which is inward. Okay, so this is all about how the ray will get reflected on when it is incident on curved surfaces. In the next classes we are going to study completely about what characteristics these mirrors have and what kind of images they can cast and all that. Is that clear? So I repeat the whole thing again. This is a plane surface and you have the normals. It's very easy for us to understand that this is making an angle of 90 degrees. The same, take a rubber pad, a plain rubber pad, and then insert the normals, that is nails here. You can also take the awl pins and then next fold this into a curve or bend this into a curve where this is a concave curve and you can see that all the nails tend as if they are going to meet at a point, and if you extend the lines you can see that this point is the center of curvature. And the other one is the other way around, you are bending it and you can see that the nails get diverged away and here the nails are converging. There the nails are getting diverged. And then we took the concave mirror. You know the principal axis. You know that the normal passes through center of curvature. This is incident ray making an angle of I with the normal. This is a reflected ray making an angle of R with the normal, and from the first law you have angle I is equal to angle R. Similarly you did it with convex mirror. So now children, now your job is to draw the whole thing, understand the concept, and for drawing also I already said that there is a sequence. You have to first take the mirror, then principal axis, then again normal, and then the incident ray. Finally comes the reflected ray. Okay, pause the video for a second so that you can see what is there on the screen, or you can also take the screenshot. And this is for our school children. For the people, like, because we are publishing it, so even outsiders will be watching the video. Just I wanted to say that we are from Modern Mission High School, Boinpalli, which is awarded by Brain Freed organization as the best available, the best state board school in Hyderabad. We are one of the best state board schools in Hyderabad. Those who want to inquire for admissions, you can call on this number 9951343026. Thank you.